Hello, friends. We are in our fifth lecture for our solutions unit. We're talking about precipitates today. So we're going to predict if precipitate is going to form or not when two solutions are mixed. And these are solutions of solutes dissolved in solvents. If I mix two of them together, am I going to get something to precipitate, fall down to the bottom of the container? Solid forms. We've heard of precipitate in terms of weather, and I mentioned it in the last couple of videos in terms of chemistry, but let's clarify what it really means. Precipitate in chemistry means that a solid, insoluble, product is formed and falls out of solution. So precipitation in living environment and earth science is like water falling from the sky. In chemistry, it's a solid material, a compound, falling from the liquid to the bottom of the container. It also signals the end or completion of a precipitation reaction. So when you get stuff falling to the bottom of your beaker, you know that the reaction is done or finishing. So let's talk about our notes here. Solubility on table F. Table F tells you what substances are soluble or insoluble. Again, soluble does dissolve, insoluble does not dissolve. It's used to make predictions, whether or not a precipitate's going to form when two solutions are mixed and undergo a double replacement reaction. So we're reviewing back to types of reactions here. All these precipitations are going to be double replacements. Technically, a precipitate is insoluble. It falls to the bottom of a mixture or solution following that double replacement reaction. A precipitate will form, or a visible reaction will occur, if one or both of the products listed is insoluble. This is a precipitate. So what's a precipitate? It's that stuff, that insoluble stuff that falls to the bottom of a beaker after a double replacement reaction has occurred. Moving on, this is table F. This is a chart that is somewhat challenging to understand. The most important key terms are right here: soluble and insoluble. There's always exceptions to the rules in chemistry. Now, I'm not going to go into detail on this chart right now because we have to do a lot of practice regarding this just so you can understand it. There's 4 columns. We'll work through this chart as we go. How to use this table. You got to find one of the ions in your formula in either column 1 or 3. There are only 2 positive ions listed in table F, so it's more likely that you find the ion in the back of your formula before the ion in the front. So we're looking for these chunks in our formulas when we're using this chart. We're playing the matching game and seeing where it falls, either in column 1 or column 3. We got to find these back part chunks in our formulas and see how they apply. So check if there's exceptions to that, if it's soluble or insoluble. So you read up to the top. If there's no exceptions, look to the top. You find if it's soluble or insoluble. If there is an exception, you have to decide if it's soluble or insoluble. So let's do a couple of these because the only way we're going to get it is practice, 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 practice. So we're looking at KNO3. Flipping back, we got to find a K or an NO3. Well, K, I don't see a K anywhere, but I do see NO3 right here. And it says nitrates, as NO3, are soluble compounds, and there's no exceptions. So KNO3 must be soluble. Okay. CaCO3. So let's look back. We're looking for a Ca or a CO3. What are we going to find first? Ca. Well, there's a Ca there, but that's not paired up with a CO3. No. Let's see. Oh, there's CO3. And they are, let's see, insoluble unless combined with group 1 ions or ammonium. Well, it's not ammonium, and Ca is in group 2, so this stuff must be insoluble. We read to the top of the column to see what it was. MgSO4. Let's find it. Are we going to find the Mg or the SO4 first? Oh, there's an SO4. I found it there. Is there an Mg anywhere? Nope. So SO4 sulfates are at the top of this column soluble unless combined with silver, calcium, strontium, barium, and lead. Well, Mg is not one of those, so this must be soluble. Now the last one, NH4OH. Let's see where we can find that one. NH4OH. NH4. There's NH4. And there's OH. Okay, so NH4 is ammonium. It says they're soluble, and there's no exceptions to the rule. Okay, let's check out OH here. OH says it's insoluble unless it's combined with group 1, calcium, barium, strontium, or ammonium. So ammonium says it's soluble no matter what, and hydroxide says it's insoluble unless it's with ammonium, which is soluble, so this last stuff must be soluble. Okay, let's see what else we got for us. So lots of practice on that. Solubility is a measure of how much solute is going to dissolve in a certain amount of solute at a given temp. So soluble means all is going to dissolve, aka miscible. It will mix, it will dissolve. Insoluble is not going to dissolve. Simple enough. Concentration is a ratio. It's a calculation, if you will. Amount of solute per amount of solvent. So it's like, how much sugar did you put into your iced tea? Or how much salt did you put into, the water, trying to trick somebody? It's a ratio. A little bit or a lot of it. So it's a calculation that comes out of that. Dilute. This is the definition of dilute is there's a relatively small amount of solute stuff dissolved in a relatively large amount of solvent. This means that the solution is kind of weak. It's to weaken the concentration of a solution. So this is like a couple grains of salt dissolved in a big bucket of water. It's very diluted. And the ratio that you can see here is the solute is small number over the solvent, which is big. So the dilute is when you have very little bit of solute divided by a very large amount of solvent. Now let's talk about concentrated, because it's got to be opposite. A relatively large amount of solute dissolved in a relatively small amount of solvent. It's a relatively strong solution. So this would be like strong coffee. Lots of coffee grounds dissolved in a very little bit of water makes a very strong coffee, or a lot of sugar dissolved in a little bit of water makes very strong iced tea solution. So solute, large word, over solvent, small. So that's mostly concentrated. Difference between the two. Most versus least concentrated using table F. So strong versus weak. Concentration is directly related to the amount of stuff that can dissolve. So most concentrated is the soluble things that will dissolve, and the least concentrated are the insoluble compounds. So maybe only a couple atoms of those dissolve in the solution, but the most concentrated are the ones that do dissolve in solution and are soluble according to table F. The least concentrated ones are the insoluble compounds according to table F. Reactions in table F. So when we're going to do reactions, we ought to be able to do the double replacement. So the examples, silver nitrate, sodium chromate, are mixed together. Will a precipitate form? This is the type of question you might see. If so, what's the name of the precipitate? Well, the first thing you got to do is write the chemical or word equation for the double replacement that's happening. So silver nitrate, we're using table E to figure that out. And sodium chromate, we use table E to figure out the formula and the crossing down technique. They react. And we got to make the double replacement. So the silver swaps with the sodium, and the nitrate swaps with the chromate. So therefore, we have this new situation: silver chromate, see that, and sodium nitrate. So we did the double swap, so the ions changed. And now we got to check to see the solubilities for the products on table F. So we're going to check these on table F: silver chromate and sodium nitrate. If you look at silver chromate, on the table F, it says that it is insoluble, so that it would make a precipitate. And therefore, it would also make a dilute solution. And just from the previous slide of notes. So let's try a couple of these before we go. So will a precipitate form when lithium nitrate is mixed with potassium phosphate? This is another example. Lithium nitrate, we figured out our formula from table E. Potassium phosphate must be this other one. And we did the swap. We swapped the first parts with the second parts. That's called a double replacement reaction. And all of these will be double replacement, so you do the double swap. Now, in this example, we're going to do AgNO3 and KCl. So we're going to do the swap first and see what we get. So we get AgCl and KNO3. So now I look at my table F, and I see that silver chlorides, let's flip back here, make sure we got table F right. So let's find our chlorides and silver. Here's halides, chlorides. It is soluble unless it's combined with silver. So silver chloride is insoluble. Now let's check KNO3 to make sure. Well, there's nitrates, and there's no exception. So all nitrates are always soluble all the time. Let's go back here. So we're going to circle the one that makes a precipitate. So that would be AgCl. That would be the precipitate, and it would fall to the bottom of the container. These other compounds, we will do the double swap here. So CuOH2, and crossing down technique is how I figured out my formula there. And then Na2SO4. All right, I want you to check these on table F to see if a precipitate is going to form on either one of them. So lithium chromates. So let's do NH4, 2, CrO4. That's ammonium chromate, and lithium nitrate. Those are our swapped, double swapped products. So you check your table F to see if there's a precipitate. Circle it if there is. There might not be, in which case you wouldn't circle anything. Check them out. So this stuff is hard to use table F, so you got to put the time into practice packet pages 10, 11, and 12. There's also a prep for a quiz on Castle and a quiz on solubility rules on Castle. So at this point, you have to have the basics of how to use table F to at least begin to figure out how to do the double replacements and figure out if precipitate is going to form. So check out your checklist. What did we just get done here? Let's see. We got lecture 5 taken care of, so check that off. We got a lab for you to do on this. It's a pretty straightforward lab as well. You got a practice pack, 3 pages, and you got a quiz to take care of on that material. So thanks for watching. See you in class.